Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Today, inshallah, we will continue our lectures. Today, I will talk about continuity, and hopefully, we will be able to cover all of those. I was hoping today also to go to partial derivatives and to go to differentiability, but I will delay it for the next lectures, inshallah, as the content of this lecture is a little bit dense and it would need concentration from you. As I told you in the previous lectures, we already initiated the limits. How to deal with limits, how to deal with limits in Rn or in multivariable functions as we saw previously. Evaluation of the limits using the definition or the directed method or the directed method, all of this we will use it through continuity. Actually, we usually go through functions, definitions of functions and so on, then we extend our knowledge to limits, and both of them, they will be needed in the part of continuity, as you will see today. Continuity and the limits are really very connected to each other, and you will see the resemblance in laws and in everything, even in the way of proving or getting the result of certain studying the continuity, of certain functions. It's all about limits. And you will see the limits and the continuity, they will be required in the analysis of differentiability that will be that we will go through in the next period, inshallah. Okay, as I told you today, we will finish the definition of continuity and the probabilities of continuous functions with some very important theories by the end of this lecture, inshallah. I will start, of course, you know that model of SVE is really very good platform. It is equipped with all the slides and with all the resources, either in PDF or slides or vids, plus all the recorded lectures, you will find them on my YouTube, so you should be in a very good shape. But just please, the only advice that I'm always insisting on telling you about is please try to resolve the problems, try to solve using your hand, try to solve as much as possible. It will make you comfortable with the proofs, with how to answer the questions, and also you will be near the exam questions as you will see. In this session, the topics under consideration is going to be the continuity at a point which mainly the main issue or the main measure of our study, and it is the main stone for whatever comes after. Then we will study the continuity in a set which depends on good understanding on the continuity at a point. Then continuous extension, how to extend the continuity to a function as we will see. Okay, functions, as you know, is very important. I've tried to put this slide for you because it's also an insistence on the importance in functions and their applications. So, mainly you know that functions are very important. It have endless applications. Usually we are interested in showing the impact of a change of a function argument on the image of they produce. Mainly, as you know previously from the previous lectures, we have the functions. The functions, it's a relation connecting the arguments Omar and the images of these arguments. So I have an input and I have an output. Functions, it's controlling this action between the input and the expected output coming from these functions. This is why it is really, very important to study them and to study the continuity and the meaning of it. So in general, it is very nice to have a smooth transition of functions on their domain, which means once the arguments are changing, you still have the images extending or changing, but in a smooth way. In this case, your function is predictable, and you can predict the values of your function. And so it is a smooth function and well-behaved function. So once more, in general, it's very nice to have a smooth transition of functions on their domain, their input. That a small change in the arguments leads to smooth changes in the images. So once you make a smooth or a small change in the arguments, in the input of your function, you are expecting the same from the images. But unfortunately, however, this is not always the case. Sometimes small changes in the arguments will lead to a huge change in the image of the function. Look to this example. It's a standard example, and it's explaining the jump that may happen in the images due to a simple change in the arguments. Let's take this example. For example, if you order something online, if you are ordering anything from online, a pizza, whatever, clothes, whatever, okay, and it has free shipping after a certain amount, and usually it goes like this. If you are buying from our website above certain amount, then you will have free shipping, as you can see. The change in the overall price will change dramatically below or above this limiting. So if I'm limiting the free shipping at a certain value of your input, so around this point, below or above, there will be a dramatic change in the prices because the shipping price will be added to your bill. And that's a very good example about the period that you have without exceeding the limit, or once you are exceeding this limit. So once more, if you are buying something from the shipping, from online, and you are going to have free shipping after a certain amount. The change in the overall price will be different once you come below or above this limiting amount, even if the change is very small, but it depends on the change of the limiting amount. So once you are near this amount, if you are below this amount, you will have to pay shipping. If you are above this limit, then you will have a different bill due to the release of the shipping from you. This is the importance of studying the continuity. That's an example, of course, of what we mean about the smooth transition and the jump that you can expect in the images. This is the importance of studying the continuity of a function. We will cover the details of this point continuity in this session, inshallah. Type continuity at a point. The main issue or the simplest definition that I want to be in your mind is the limit when x tends to a for an f of x is equal to f of a, which means the limit equal the definition of the function. The limit equal the value of the function. So actually, the limit of the function when x tends to a is exactly equal to the value of the function at that point. That means your function is continuous. In drawing or in graphing, a continuous function means you can graph your function without tracing your pen from the drawing board and walking back. This is what's called a continuous function. So once more, what's the main condition? It's the simplest definition, that the value of the limit should equal the defined value of the function, or the value of the function at this certain point. So once more, let's consider a function. This definition we will see written in many forms. But the bottom line, as I told you, the value of the limit equal the function at this point. What the value of the function is. In this case, your function is continuous. So once more, let's consider a function and then avoid in its domain of definition. So if such that's the domain of the function, which is a part of Rn into Rn, where a belongs to the domain of your function. Okay, we say f is continuous at the point a if its value, f of a, coincides with the limit at a, exactly as I told you. Okay, a function is continuous at the point a of its domain. When the argument gets close to a, the images get close to f of a. Look to this example, one of the nicest examples that you will have, and the simplest one too, and I will deal with this example in many slides, as you will see. So if I have f of x, and it's a piecewise function, which is defined in more than one domain. It's defined as 2x minus 1 when x doesn't equal to 1 or 3, or f of x is equal to 3 once x is equal to 3, which represent, for whenever x doesn't equal to 3, it represents a straight line, as you can see. The function in general, it's not defined at x equal to 1, and it has a different value at x equal 3. If your function, when x equal to 3, just put the value of the function to be 3, as you can see. Okay, if you look to this function, you will find the following. That this function at 4, for example, it is continuous. I can draw the line without leaving my hand and putting it back on the drawing board. So it's a continuous function. Another thing, Mr. Omar, that the limit of the function coming from the left and coming from the right, it will tend to the value of the function at this point, which is 7. That means the limit equal the definition or the value of the function. And so the function is continuous at 4. But let's look at 3. If I'm trying to draw, first from the graph, I will move like this, and then I will raise my pen, put it here, and then continue. So already you had to raise your pen from the drawing board and put it back. So it's not continuous. Also, another thing, if you remark the approach of x to 3, this is x trying to approach the value of 3. This is the function trying to reach or to approach the images. The images is coming near to the point 5. Or to the value of 5, which is completely different than the value of the function at 3, which is given by 3. Bottom line, once more, if you look at the value of at x equal to 4, you will find the following. The images will tend to 7. Also, the value of the function is equal to 7. So, limit x tends to 4. For 2x minus 1 is going to be 8 minus 1, which is 7. Which is exactly the value of the function at 7. This is why it is continuous. But once more, this is the value at 4. So as you can see, this is x equal to 4, and it is equal to the value of 7. The limit equals the definition of the function at this point. While if you look at x equal to 3, you will find that the limit when x tends to 3, if you try to evaluate it, it's going to be 2 times 3, which is 6. Minus 1 is going to be 5. But the value of the function at 3 is given by 3. So they are not the same. They are not equal to each other. So from this definition, the function is not continuous at 3. So once more, that's if I'm studying at 3, you will find this is the limit at 3, which is equal to 5. And that's the actual value, which is completely different. See the difference between the 2 points? Due to this difference, your function is not continuous at x equal to 3. So now I have this simplification of the definition of a function continuity. Also, once more, if you look to this function, the function in black, if you look to x tends to a, you will find and discover the following. That the limit of the function is equal to a, and the function value is equal to a. So actually, f of x tends to f of a, while x tends to a, which is exactly the definition of the limit. While in these two cases, in this case, first of all, the limit doesn't exist. The limit doesn't exist. So for sure, the value of the function at x equal to a is not equal to the limit, so the function is discontinuous. And also, in this case, the limit of the function is something, and the definition is something else, so they are not equal to each other, so they are both discontinuous. So that's the limit doesn't exist, and that's the case when the limit coincides with the value, doesn't coincide with the value. So either these two cases represent a discontinuous function as usual. So once more, definition of f, continuous at the point x is f and only f. This is the definition of the limit that we took in the previous session. That's the definition of the limit that we took in the previous session. Okay? And that's the definition, the limit definition by the first principles. We really knew that we will use this definition in the cases we are trying to approach the limit from any side. That's the only way to find a limit in several variables, in the case of functions, in several variables. Okay? Okay, very good. Right. Let's see what's the difference between this definition and the limit definition. In the limit definition, for every delta greater than 0, there exists epsilon greater than 0, such that x minus a less than epsilon, which will lead in f of x minus b, which is the limit value, is less than delta. Then it is, the limit exists, and so on. Here in the continuity, the only condition is while x tends to a, the function f of x should tend to in specific to the value of f of a. That's the only definition. Once more, if you don't remember the definition of the limit. The definition of the limits is exactly like this one. Absolute x minus a should be less than epsilon, which leads to, okay, once more, f of x minus b will be the value of the limit. It's supposed to be less than that. But in continuity, instead of having this value, it should just only equal to the value of the function at the point that you are studying the continuity at. Of course, if you remember this relations, of the limit definition, it will be very clear for you. So once more, a function is continuous at a point A of its domain, when it is possible to ensure that the image of f are as close as we want to f of a, as long as the argument are close to a, and that's the definition mainly. I can prove it once more using the general straight line equation y equal mx plus b, which is an equation of a straight line. An equation of a straight line represents a continuous function. So that's the general case of y equal mx plus b. Look, Mr. Muhammad, this is the epsilon in the x in the argument. So actually this is a plus epsilon, a minus epsilon, which means x minus a is less than epsilon. That's what you are doing in the definition. And it should lead to that the difference f of x minus f of a should be less than delta. That's the definition of the limit, okay? And also the definition of continuity once the limit value is equal to the value of the function. If I want to apply the definition, it's going to be f of x minus f of a. Let's do it together. F of x, which is going to be mx plus b. And f of a will be the value of this function, but at x equal to a. So it's going to be minus m a minus b. Okay, try to simplify your life. So b will eat negative b, take m as a common. You will have m x minus a, take m as a common. It will be an absolute of x minus a, which means you have the relation connecting epsilon and the delta both together. So once more, that means an absolute of m equal x minus a less than delta, which leads to this part leads to, I know that x minus a is epsilon, which leads to that for epsilon less than delta over absolute of m, that's the condition for, or there exists a value which is greater than 0, as you can see, which proves that the limit exists and the function is continuous. So once more, it is exactly the same. The limit definition, it is the continuity definition. I know it's hard a little bit to digest if you didn't try to do so in limits. So for studying this part of Mr. Saif, you will have to follow first the limits. Because once you understand the definition of the limits, it's exactly the same with the continuity, just only one difference, that f of x minus, you know the value of the limit, which is supposed to be f of a. Okay? So it's gonna be really very straightforward. And once more, I want you, please try to write. Please try to write. After we finish, I have some comments about your midterm Congratulations first, I think most of you did well in the previous exam, and hopefully it will be the same with the next one, if possible, inshallah. Hope you understand, try to work as much as possible within the coming period to be able to get and guard your grades within the first midterm. But after we finish, I have serious remarks about your resolution in the previous exam, okay? So once more, and according to the definition of the limit coincides with the function value, as I told you, it's exactly the same. Let's go through deeply in this example. بص، المثال اللي انا هتكلم عليه دلوقتي اولا محتاج تركيز من نار. لانه هيشرح لك، هيديك خلفيه ايه هي الفكره بتاعت الليمتس تاني بيأكد عليها. يعني بص، الكونتينيوتي من ساعه ما انا بدات المحاضره ما بتكلمش الا عن الليمتس. ما هو الكونتينيوتي دراسه ليميت. فاهمني؟ هي تعريف الفانكشن، يعني الفاليو بتاعت الفانكشن والليميت الاثنين سوا بعض. يعني ايه فانكشن كونتينيوس؟ يعني الفاليو اوف ذا ليميت ايكوال الفاليو اوف ذا فانكشن ات سيرتن بوينت. الاثنين سوا بعض. يعني معنى كلامي ان العمليه كلها ليميتس. انا هتكلم دلوقتي على الاكزامبل يا حازم، سيب الموبايل. يعني انا قاعد عمال اكلمك، انت مش سامع كلامي خالص، قاعد عمال تلعب في الموبايل. ماشي؟ خلي بالك انا هتكلم دلوقتي ان سبيسيفيك على الخط المستقيم ده، وهحاول اقرب، حاول تفهم قوي النقط اللي انا هتكلم فيها، لانها فعلا قريبه جدا من بعض. وانا بذلت فيه مجهود مش هتتخيل عشان احطه لك بالمنظر ده. تعالى بقى تابعني كده ستيب باي ستيب. Okay, once more, I will get back to the main definition. تاني, I want you to know how to write this definition. I need to prove that for every, once more, delta greater than 0, there exists an epsilon greater than 0, such what? When the arguments x minus a become less than epsilon, this will lead to, listen, will lead to that the difference between f of x minus f of a will be less than delta. That's the definition. Safe, what's the difference between this definition and the definition of the limit? Nothing. Just only this guy is b. So if I want to find the limit of f of x and it's equal to b, any value, that's the definition. But if I want to prove that this function is continuous at this point, I have to be sure that this guy is f of a. Are you listening? It's exactly the same formula, exactly the same steps. It's a limit. Okay? So once more, as I told you, you're not going to be able to do this unless you try to solve as much as possible from problems. As much as you practice, you will be able to write a statement like this. So it's really essential that you will have to rewrite it. This is why I'm telling you about this. So once more, okay, this is the function from Rn into Rn, so we are generalizing the case. And for every delta greater than 0, there is a epsilon greater than 0. That's x minus a less than epsilon will lead to f of x minus f of a less than delta. This is what I want to show you. Okay, let's get back then once more to our example, which represent a straight line. اللي بالك حازم صح؟ Okay, which represent a straight line. بص على straight line اللي بيقول لك ازاي. بص ازاي؟ It is y equal to x minus 1, an equation of a straight line. بس خلي بالك, it's not defined at how many points? It's not defined at 1 or defined at 3. But if it is equal to 3, if it is x equal to 3, consider the value of the function is equal to 3. So it's merely a straight line, except at x equal to 1 is not defined. مش عارفين لها value. But when x equal to 3, you are not going to follow the equation. No, put it equal to 3. So once more, that's the shape of my line. That's the line that we are drawing. Okay? As you can see, it's not defined at 1 and at 3 and at 1. It's not defined at these two values. Okay, I will start, at 3 and at 1. I will start my study at 4. I will study at 4. So at 4 it's supposed to be continuous. Am I right?
Yes.
The function and the limit equal to each other. Let's study this case step by step. I will study through the limits by considering delta some value greater than 0. I will choose the value. I will choose the case when delta is equal to 6. Let's do it delta equal to 6. So all I want to do is to have f of x minus f at 4. This is the definition. And supposed to be less than what? Less than 6. Okay. Guys, f of x, I know the function. What's the function in this situation at x equal to 4? It is 2x minus 1. So, what's the value of the function at 4? You will use the first branch. So it's gonna be 2 times 4, which is 8 minus 1, which is 7. Here we go. That's the function. Let's see. 2x minus 1 minus 7, which leads to 2x minus 8. Take 2 as a common, you will have this guy, which leads to Mr. Muhammad that 2 epsilon is less than 6, which means epsilon less than 3. Here we go. That's x minus 4 is less than 3, which means epsilon at 6 is equal to 3. Are you with me? So a difference within 3 margin from 4, x equal to 4. 3 from the left, 3 from the right. A margin of 3 from both sides will lead to a margin in the image equal to 6. Are you with me? This is why you can see 4 plus 3, which is the boundary using this guy. 4 minus 3, it's another boundary. And for this guy, this is the value. And that one is f4 minus 6. If you try to get the difference between the function, these two limits, you will find it is less than 6. So the limit exists. Once more, x minus 4 less than 3 will lead to f of x minus 4 less than 6. معايا حازم؟ فاهم انا بقول ايه؟ لا. تاني once more. x minus 4 is equal to 3. يعني ايه؟ يعني كل النقط اللي هنا اهو اللي بتوين دول، يعني كل النقط دي الفرق هنا x minus 4 فاهمني؟ بيساوي الفرق اللي هنا بس 6. ده معنى كلمة ليميت، إن كل ما الفاليوز بتقرب للبوينت الايمجز بتقرب للفاليو of the function at this point. معانا سيف؟ يبقى اوكي it is existing. This is happened at lambda equal to 6, which means they are continuous. The definition is correct. Okay, once more. I will try to do it on 3. بس قبل ما اكمل على 3 بصوا كده. انا بقول لو x minus 4 less than 3 يبقى f of x minus f of 4 less than كام؟ less than 6. طيب تعالى كده معايا. 4 plus 3 دي كام؟ 7 صح؟ 4 plus 3 بيساوي 7. طيب تعالى بقى خد 7 اللي هي f اللي هي 7 اللي احنا قلنا عليها انا اسف 4 plus 3 which is 7 وخد الفاليو بتاعت ال 7 وسبستيتيوت هنا. 2 times 7 14 minus 1 13 صح كده؟ This is the value at f at the end of your value. That's the value of f of x. يبقى إذا عندي 13 صح؟ minus f at 4. f at 4 بكام؟ 7
ماشي
صح؟ يبقى 13 minus 7 يجي لك كام؟
5
وال5 أقل من كام؟
من 6
يعني أنا صح؟ مش كده برضه؟ روح على الأذر ليميت. لو أنا نزلت لغاية 4 minus 3 4 minus 3 ده بكام؟ 1 خد ال 1 f 4 خد ال 1 بتاعي وعامل فيه سبستيتيوشن في الفانكشن. يبقى إذا ده هيبقى 2 minus 1 بيساوي 1. تعالى هات الديفرنس بين 1 and 7 اديك 6. طبعا انت هنا عند الليمت في الاخر المفروض انه قبليها بصيغه بسيطه لان انا قايل لك انه x minus 4 less than كام؟ 3. يعني اذا معناها انك هتحصل على 6 which means it's correct. يبقى الديفينيشن in most cases by the boundary from the left or from the right it coincides with what you expect. That x minus 4 with a margin less than 6 less than 3 leads to the images of the value of the function minus f at 4 is less than كام؟ 6.
minus 1.
اتفضل.
هو على اخر واحده قلنا اللي هي هتبقى ايكوال 6 فهو ازاي 6 موزن 6 مش المفروض تبقى موزن ايكوال؟
حبيبي ما هو انا هنا مش حاطط ايكوال صح؟ في ايكوال؟
لا
يعني اذا مش المفروض ان انا البس 1.
ماشي.
المفروض اكون قبل 1 بسنه بسيطه.
ماشي ماشي.
فحتى لو انا خدت الباوندري او 6 يبقى البيكسلز لو انا واخد فاليو اقل من ال1 اكيد الفاليو هتبقى اقل من الفاليو بتاعت 6.
ماشي ماشي.
دي الفكره. in a similar manner بنفس الاسلوب بالظبط. تعال نقرب. انا هنا واخد اللي بالك انا واخد هنا دلتا بتساوي 6. طبعا بالتاكيد له معنى تاني انتوبولوجي. المعنى بتاع الانتوبولوجي كان بيقول ايه؟ كان بيقول ان الاوبن بول سنترد ات 4 الراديوس بتاعها بيساوي كام؟ هيؤدي الى ان الاوبن بول اللي سنترد ات اف اوف 4 يكون اقل من كام؟ من 6 صح كده؟ طيب ايه رايك لو انا حبيت اصغر شويه الدلتا؟ طبعا هنا مفيش حد قال ان دلتا ب 6 او دلتا، خلي بالك ان ده بالفانكشن. اوكي؟ طيب تعال نجرب لو دلتا بتساوي 3.
ماشي.
حازم تعال اعملها معاك. لو دلتا بتساوي 3 هبدا منين؟ اف اوف اكس صح؟ ماينس اف اوف 4 اتس سبوست تو بي ليس ذان كام؟ 3. ليتس دو ات توجذر. هذا اف اوف اكس ماينس اف اوف 4 ليس ذان كام؟ وانس مور الاف اوف 4 بكام؟ 7. سهله مفيش فيها حاجه. اهي بص 2 تايمز 4 8 ماينس 1 7. يبقى اذا انا هاخد اف اوف اكس ماينس 7 اهي. ادي اف اوف اكس ماينس 7. لما اعملها كده هيدي لك 2 اكس ماينس 8 يعني دي تبقى اهي 2 اوفر اكس نيجاتيف 8 ابسولوت تيك 2 از كومن يفضل اكس ماينس 4 مش كده برضه؟ يعني دلوقتي اقدر اقول ان 2 اوف ابسولوت از ليس ذان 3 يعني ابسولوت ليس ذان 3 على كام؟ في مشاكل؟ يبقى اذا لو انا عندي 3 اوفر 2 يبقى اذا ام اكسبكتنج ان الدلتا ويل بي يقدر كام؟ 3. بس انا هنا عندي تعديله صغيره بالنسبه للرقم ده. لان انا واقف عند 4 صح؟ وباخد الريديوس ب1.5 يعني 4 زائد 1.5 يديك 5.5. طيب 4 اشيل منهم 1.5 يديك كام؟ يديك 2.5 مش 4 تشيل منهم 1.5 يبقى هيوصلك 2.5. بس انت لما تروح عند 2.5 عندك مشكله. انت عديت بال3 اللي هي اوبن. فعشان تو افويد ذس انا هختار هنا ابسلون بس لغايه 1 يعني بدل ما يبقى ليس ذان ايكوال 1.5 انا هختاره ليس ذان كام؟ 1. مش انت عايز ابسلون يكون اقل من النمبر ده؟ خلاص انا هختار ابسلون اقل من كام؟ من 1. طب اشمعنى؟ جاست تو افويد ان انا المس رقم كام؟ رقم 3 او اجي جنب رقم 3 لانه 4 ماينس 3 يديك الليميتيشن ات 3 بالظبط. هي البوينت عندها كده. اوكي سو وانس مور اهو خلي بالك ان الديفينيشن مظبوط. تاني اهو ادي 3 اوفر 2. انا طبعا روت الديفينيشن ده لاني ببعت لك السلايدز فروتت هنا اهو. Remark that if epsilon is equal to 3 over 2, this means that the interval around x equal to 4 will be 2.5 up to 5.5. Which means you will pass by x equal to 3. So it's better to limit it to epsilon equal to 1. Okay? In order to make it as clear as possible. So now for epsilon at delta equal to 3 it's equal to 1. لو انا عملت التست بتاعي it makes sense. انه for x minus 4 within the open ball with radius 1 the results will be less than كام؟ less than 3. If you want to check we can. Let's check once more for the last time. خلي بالك انا بعمل التشيك ده مش عشان بس ابسطك. بعمل لك التشيك ده لانه مهم. هيبقى له معنى قدام. طيب تعال نجرب ده. طيب انا هنا عندي 4 بلس 1 يديك كام يابا؟ 5. خد ال 5 اعمل بيه سبستيتيوشن. 5 تايمز 2 ماينس 1 ها ماينس 1 يديني 9. اوكي يبقى اذا الديفرنس بتاعي فوق ده عباره عن 9 ده بيساوي 9 ماينس 7 ده كام؟ which is less than كام؟
3.
يعني اذا ده الكلام ده مظبوط. انت لما خدت between x minus 4 و less than value يعني within the epsilon اللي بيحقق ده طلع الكلام ده صح ان f of x minus f of 4 less than كام؟ less than 3. تعالوا نجربه تاني. هاخد عند 4 minus 1 which is 3. تعال عوض بال 3. طبعا انا مش بعمل سبستيوشن بالظبط هو المفروض قبل 3 فاهم بس انا يعني جوازا يعني هاخد 2.999999999 not 3. Let's take it. اوكي 2 times 3
6
6 minus 1 اوكي تعالى هنا 5 minus 7 نيجاتيف 2 وال 2 دي ليدر كام؟ ليدر 3 يعني اذا كوريكت يبقى فعلا ما غلطش قال لك لو انا خدت اوبن بول حوالين 4 الريديوس بتاعها بواحد هيؤدي it will lead to that the image the open ball at the image will be ليدر كام؟ دلتا الكلام كله مظبوط صح؟ تعالى نصبر اهو ده الديفينيشن ان جنرال ده 6 عشان انا بس بقلب السلايد عايزهم يبقوا قدام عينيك ده عند دلتا بتساوي 6 وابسول بتاعها ب 3 كان ده الشكل ده عند دلتا بتساوي 3 وكان الابسول بتاعها بكام؟ بيساوي 1 احنا عملناه طيب what if we tried to take an epsilon equal to half around 4 يا ترى في difference؟ let's try it okay I will go through it when delta is equal to 1 if delta is equal to 1 then I will have f of x minus f of 4 less than 1 بعدين I will make the substitution شايف؟ make the substitution محمد يبقى 2x minus 1 minus 7 which will lead to 2x minus 8 take 2 as a common يفضل عندك x minus 4 which is epsilon يبقى epsilon less than half صح؟ يبقى انا هنا لو انا رحت هاف يمين وهاف شمال will lead ان الديفرنس in the images will be 1 صح كده؟ طيب تمام حلو جدا يعني اذا وبرده مظبوط لو انا خدته وحاولت اعمل ترايلز تطلع مظبوطه برضه طيب اوكي جميل جدا يعني اذا x minus 4 less than half will lead to f of x minus f of 4 equal to 1 which is the minimum value let's do it in general بقى لو انا حبيت to generalize it once more ادي عند الفاليو عند 4 plus delta 4 minus delta are you with me okay once more يبقى f of x minus f of 4 less than delta do exactly the same so it's going to be 2x minus 1 which is led to 2 of x minus 4 يعني epsilon is less than delta over 2 يعني اذا انا I can take delta the minimum between the 1 and delta over 2 if I choose it's supposed to be 3 over 2 بس انا avoid 3 over 2 to have it as 1 in order to avoid any problems around x وطبعا انا كتبته لك اهو في الكتاب يبقى اذا for every delta greater than 0 there exists an epsilon okay greater than 0 برضه which is the minimum of